Saeed Nikju for demand forecasting in Dynamics 365 supply chain management using Azure machine learning. Saeed, the floor is yours.
Thank you, Colin. Demand forecasting is the process of predicting future demand for products or services. In this session, we will explore the demand forecast functionality in the master planning module of D365 combined with the power of Azure Machine Learning Service. By the way, all of the content of this presentation is customer ready, so please feel free to share it with customers and partners. First, I would like to take some time to review the basic concepts of forecasting to understand how it works in D365. Why demand forecasting is useful for business? As I mentioned before, forecasts allow to predict future demand, and we use that prediction to drive business decisions. Demand forecasting helps business to reduce costs by reducing on-hand inventory, for example. Also, companies can order or manufacture products that take a long time to produce before getting the customer's orders. In other words, we are decreasing lead times. That is a goal of supply chain management. Finally, an accurate demand forecast helps mitigate stock out situations by ensuring sufficient inventory levels to capture all potential sales and increase revenue. The main strategy to generate a forecast in D365 is time series forecasting. Time series forecasting refers to models that use historical demand to predict future demand. We can break the general components of a time series forecast model into three buckets. First, we have
Saeed, you went on mute.
Oh, thank you. I was saying that we can divide time series forecast into three buckets. First, we have the trend. Trend is the general direction which demand moves, increasing or decreasing. Next, we have seasonality. Seasonality represents short-term patterns in our demand. For example, we may have a trend in demand where we see a spike at the end of every quarter or in the summer months, for example. Next is the error or noise. Refers to unexpected random variation in our time series. There is no way to create a model that will explain our trend and seasonality with 100% accuracy. So always we will have some errors. We can predict the future demand when we add the three different components together. In D365, we can use different machine learning models that calculate and combine these components in different ways, allowing the system to compare and select the best model. When we generate a forecast with a time series model, we use the demand history data points to build the forecast equation. Let's review the process in high level. So we start taking a subset of demand history data using the parameters that we have set in D365 and input that data into Azure Machine Learning. In Azure Machine Learning, time series model essentially create an equation like this to predict the future demand. In most cases, the historical values are multiplied by some factor. determined by the model and the parameters that we specified in D365. As I mentioned, it's normal to have an error as a part of the equation. The system determines which model is the best using an indicator called MIP, mean absolute percentage error. To calculate MIP, we take the data points that we didn't use to build the forecast equation and calculate the forecast for those days. As we can see in the graph, the MIP compare the actual versus the forecast value for our data points to find an average distance between these two time series. A MIP of 20% or less is good. A value of -1 is not a valid result. In summary, MIP value tells you how well the model is performing in terms of accuracy, and it can be influenced by the quality of the predictions of the models and also with the scale of the data. Forecast dimension. When we generate our forecast, we need to determine what dimension we will include. The mandatory dimensions are company, sites, and allocation key. Item allocation key are like labels that groups items together. We only calculate the demand forecast if that item is part of an item allocation key. You can create item allocation keys on the master planning model. If we want to be more detailed in our forecast, we have several more dimensions that we can choose: country, region, state, customer, etc. Granularity attribute. When we are implementing demand forecasting, we will see the term granularity attribute very frequently. So let's quickly discuss that was mean. So let's say that a company has chosen the light blue dimensions that we have in the slide. Company, site, allocation key, country, customer group, item number, and dimensions. Where I generate the forecast, I will get numbers for every row in this table. Each row in the table shows a specific combination of things that I'm predicting. These specific combinations are called granularity attribute. It's important to understand this because the combination of these dimensions will affect our results. For example, if we run a forecast at the customer level, it may not have the same results or the same forecast if I generate a forecast using the customer group level. Here we have the different steps of a forecast generation process in D365. First, we gather the historical data. If we don't have enough historical data, we can import historical data from the legacy systems using the data management framework. Next, we will trigger the forecast generation in the Azure side. We will create the forecast model. Once the Azure steps are complete, we can review and generate the forecast in Dynamics, update the values as needed. And when everything is good, we can authorize the forecast and publish it on the system to use in the planning and other operations. Now we will take a look of the overall architecture of the demand forecasting solution. Here we have an architecture diagram of how the forecast works. There are three main components: the demand forecasting functionality in the master planning module of D365, the Azure Machine Learning Service, and the Azure Blob Storage account. On GitHub, you can find a repository developed by the product group that contains templates, scripts that you can use to set up your Azure environment and generate the demand forecast using Azure Machine Learning Service. To start the process, we need to generate in D365 a statistical baseline forecast. This action will trigger a machine learning experiment that sends the historical demand data file to an Azure blob. In the step number 3, the machine learning experiment will split this historical data in different subsets on a specific attribute. In this case, a granularity attribute that is a combination of the forecast dimension that we specified on the demand forecasting parameters page. When we split the data, we enable parallelism, and we can process different subsets of data at the same time. This action will generate a packet file. A packet file is an open source column-oriented data format designed for efficient data storage and retrieval. So we have this packet file here. In the step number 5, the forecast is generated using a time series forecast machine learning model. In this case, we will use an R script. And finally, the last step is a combined forecast file that is saved in the Azure storage. In the output folder. Let's deep dive into the time series machine learning models that we can use in D365. As I mentioned, time series forecast refers to a model that uses historical demand values to predict the future demand. In D365, we can use different time series models like ARIMA, ETS, STL, or a combination of models like ETS plus ARIMA or ETS plus STL to generate the forecast. Finally, we have the option to use all models, which direct the system to run through all of the options and pick the model that gets the lowest MIP value or MIP error. The recommendation is to start with all, allowing the machine learning experiment to choose the most efficient model, in this case, the model with the lowest MIP error. Now let's take a look of the forecasting algorithms parameters configuration. So in this screenshot, we have a list of the different parameters that we can set in D365 to control which values should be provided to Azure Machine Learning to create the forecast model. We have short times, so I won't talk in detail about each parameter, but the recommendation is to start with the default configuration. In the default configuration, we have a 95% confidence level. Also, the seasonality is in auto. We use all forecast models. On the missing value substitution scope, we use the granularity attribute. That means the system will use the data range of the currently processed granularity attribute. Remember, a granularity attribute is a combination of the forecast dimension, which against which the forecast is done. On seasonality, we are using 12, that is equal to 12 months. And finally, we have this last parameters is the test set size percentage. In this case, is 20%. That indicates that we will use 20% of the historical data as test data points for the MIP value, and the remaining 80% will be used to train the Azure machine learning models. So this is a standard practice in data science. Now let's talk about the second component of the solution, that is Azure Machine Learning Service. What is Azure Machine Learning Service? It's a set of cloud service for managing machine learning projects. With Azure Machine Learning Service, we can prepare data, build, train, manage, and deploy models, run and track experiments. Developers can use the Python SDK or the Azure Machine Learning Studio, a graphical interface. We can also use Visual Studio Code, Azure CLI, Auto Machine Learning, and notebooks. Here we have the Azure Machine Learning Service key elements. So the workspace is a container for all of the machine learning assets in a project. Models. To create a model, we need to select an algorithm, provide data, and tuning the hyper parameters. Also, we have the jobs and experiment. An experiment is a group of many runs from a specific script. We have the pipelines. A pipeline is a sequence of steps that are executed in a specific order. It can include data preparation, model training, model evaluation, and deployment. In Azure Machine Learning, we can create pipelines using Python code or drag and drop tools in Azure Machine Learning Studio. Compute targets are used to train models and run job experiments. In this case, we will use two types of compute targets, compute instances and compute clusters. Notebooks. A notebook is an interactive environment that allows you to write and run code, visualize data, document your work. In Azure Machine Learning, you can use Jupyter notebooks. Data store are a connection to a storage service. In this case, is a direct connection to the Azure Data Storage. And finally, we have the endpoints. An endpoint is a web service that exposes your training model as an API. It allows you to make predictions on new data by sending an HTTP request to an endpoint URL. Now we will see how we can set up Azure Machine Learning Services for demand forecasting within D365. So the first step is to enable the feature and feature management. In 10.0.32 version, this feature is enabled by default, and in 10.0.36 version, the feature is mandatory and can be turned off. The next step is to go to the master planning module, demand forecasting, and set up the demand forecasting parameters. So in the general tab, we need to set the forecast generation strategy to Azure Machine Learning Service. So we have two types of service: Azure Machine Learning, that is referred to the old Machine Learning Classic Studio, and we have the new one, or relative new one, that's the Azure Machine Learning Service. On the item allocation key tab, make sure the forecast generation strategy field is also set to Azure Machine Learning Service for each allocation key that should use to the Azure Machine Learning Service for demand forecasting. To enable Azure Machine Learning Service to process the demand forecasting in D365, we need to set up an Azure Machine Learning workspace. In order to do that, we have two options. The first option is to run a script that will automatically set up your Azure Machine Learning workspace. The scripts automatically perform all the necessary steps to set up all of the required components. The second option is to manually set up the Azure Machine Learning workspace. In this session, we will go over the option one. So let's review the details on how to run the script. So the first step is to clone the repo instead of download the template files. So the recommendation here is to clone the repo. This repo in GitHub is developed by the product group. So we need to install the script dependencies, in this case, the Azure CLI and the extension that is the Azure CLI ML. Now we can run the script. So instead of running in a PowerShell Windows, I recommend to use Visual Studio Code. Visual Studio Code provides more integrated experience for executing Azure CLI scripts than PowerShell. As a next step, we can run the quick setup PS script and follow the on-screen instructions. You will need to provide an Azure subscription ID, resource group name, location, a storage account, workspace name, and a name for the Azure Active Directory application. The script will create all of the required components. We will create the resource group, the storage account, the machine learning workspace, set up a data store, create a compute instance and a compute cluster, and we'll create and register an Active Directory application. As a next step, we need to go back to the folder where we download or we will clone the repo, and we need to upload the sample input CSV file. This file is required to publish the initial pipeline and generate a test forecasts. So these are additional steps that the scripts don't do. So in this step, we will need to create a pipeline, which will provide a way to start the forecasting scripts from D365. So we need to go to the templates folder that we downloaded from GitHub in the previous step. And now we need to go to the Azure Machine Learning Studio and go over notebooks and allow all the following files. Make sure to follow the same folder structure that we have in the template folder. As a next step, we need to edit the parameters file. So we need to double check that we have the correct name in the compute cluster. So for example, here we have the compute cluster name. And also the nodes count. So this particular compute cluster that I create has 6 nodes. So we can use up to 5 nodes here. In this case, I select just 4. Once you save the parameters file, you need to go to the API trigger Python file, so this one, and run it. So we run this file. This file will create a job and also a pipeline. And now the next step is to integrate the Azure Machine Learning Service with the D365. So another additional step that we need to do is to create the service principal secret. So the script will create the app registration, but you need to create the secret manually. And here we have a screenshot that show you how to configure the demand forecasting parameters. So these are the results of the script, and you need to copy and paste the results of the script in the different fields, the tenant ID, the application ID, storage account. You need to copy the secret value here. And finally, you need to go back to Azure Machine Learning Studio, and inside of the pipeline, you need to copy the endpoint. Great. Now we will have a demo to show you how the process works. So give me 1 second. So here we have the script. These are the parameters that we need to. These are the mandatory parameters: subscription ID, resource group, location, storage account, WordSpare name, and Azure Active Directory application. Once you run the script, you can go. So give me 1 second here. So let's switch to the Azure portal to see the resource created by the script. As you can see, the script created the Azure machine, the resource group, the Azure machine learning workspace, and the storage account. Also, the script create this and register this app, and you need to manually create the value secret. If you want to go to the Azure Machine Learning Studio, so you can click here, and inside of the Azure Machine Learning Studio, you will find the compute instance, the compute cluster, also the data storage. So you need to upload the sample file, and here you will have an input and output folder. Here you have the notebooks. This is the structure. So you need to upload these notebooks manually, edit the parameters file, and run the API trigger Python file. After that, pipeline will be created and also a series of jobs. So now let's switch to the D365. In order to generate a forecast, we need to go to the master planning module and generate the statistical baseline forecast. So the first step is select an historical horizon. In this case, I am using data from 2015 because the demo data has historical data just in 2015, 2016, and 2017. But in a production environment, typically you will want to use an historical horizon that is twice as long as your forecast horizon. For example, if you want to predict demand in the next 12 months, you should use at least 2 years of historical data. So you can click here, OK, and this will start the forecast generation process. And after that, you can go to the adjusted demand forecast. So here you can see the predictions that the Azure Machine Learning Service did. And here you can view more details if you select one of the lines and forecast line details. Here you can see the historical demand. Let me go back. And also here you can see the model details. So in this case, we have a MIP error of 35%, and the forecast model that we used was ARIMA. You can also view all the history of the forecast generation here in statistical baseline forecast generation history. So here you have all the information. And when everything is good, you can authorize the adjusted demand forecast. So this will be the last step. So with that, I think we have 5 minutes for questions. Over you, Colin.
Thank you, Saeed. We do have one question in the chat from Andre. He mentions, what is the difference with the setup script and the manual setup? Are there more choices to manage parameters when manually setting up machine learning services? Are there any benefits?
No, there is no benefits to do it manually. The script, so let me show you the script. So the script will create, let me go back to this slide. So the script will create all the components that you need, and this way will be more efficient. You can do the process manually, but maybe you can forget one step of the other. So my recommendation is to use the script.
All right, another question from Russell Said. How much of the Azure machine learning service piece is applicable to the new demand planning solution set to come out in public preview? And how would you build in promotional uplift?
Thank you. Great question. I don't have the details of the new version, but I was chatting with the product group the other day, and they mentioned that all of the repo is still valid.
One more question from Neil. He says, do you need an independent subscription to Azure Machine Learning, or does D365 F&O have any entitlements for Azure Machine Learning?
You need an independent subscription to do it because the D365 license do not include any Azure resources.
A couple more questions, Said. What is the cost of generating the demand forecast within Azure Machine Learning?
Great question. So from the D365 side, we don't have any additional cost or any additional license required. So the cost is basically on Azure. You will need an Azure subscription. And in the Azure subscription, you will need to create all of these resources. The most expensive one are the compute instance. So let me show you. Go back to Studio. So for example, here you have the compute instance. So this, the cost for this instance is 32 cents per hour. And also we have additional cost for the clusters. The compute instance and the cluster are the same Azure Virtual Machine family, so the cost is the same, but you need to multiply the cost by the number of nodes. In this case, we have 6 nodes. Please note that we can also set up this parameter here to shoot down the compute result if the compute resource is idle for about 1 hour or maybe 2, you can set up this parameter here.
Thank you. Last question so far. What happens with the customers that implement the demand forecasting with older versions of Azure Machine Learning?
Great question. Thank you, Colin. So the Azure Machine Learning Classic, or the old one, will be deprecated in August next year. So the recommendation here is to migrate from the classic Azure Machine Learning portal to the new Azure Machine Learning service. So the new Azure Machine Learning Service is a modern platform to do data science that is focused on code first, but also we have a lot of drag and drop experience like the designer or the auto machine learning.